So you're asked to solve this definite trig integral, and you have even powers of secant, so I would start by simply splitting off a secant squared and then making a trig substitution. So let's see where that gets us. So you're going to do a secant squared, theta, secant squared, theta, d theta. Now you're going to replace one of the secant squares with the Pythagorean identity. So you're left with 1 plus tangent squared theta, secant squared theta, d theta. Now you'll let u equal tangent of theta, and du is equal to secant squared theta, d theta. So rewriting this in terms of u, you get the integral, and again this is theta equals pi over 4, and this is theta equals pi over 3, and this is 1 plus u squared du. Take the antiderivative of that and you get 8 times the quantity, that's just u plus u cubed over 3. Now you have to evaluate this, but these limits of integration are in terms of theta. I would rather, to keep my trig simpler, convert these to u. So put in theta into the function tangent of theta, which is what u was when we started the substitution, and tangent of pi over 4 from the unit circle is 1. Tangent of pi over 3 requires a little bit more work and knowledge of the unit circle. So let me just go off and make sure we're good. Remember, the tangent function, right, is equal, tangent of theta is equal to the y component over the x component. If you remember the unit circle for pi over 3, right, that point on the circle, y is the square root of 3 over 2. That's a 3. And, oops, I'm sorry, reversing it. The x component is a half, and the y component is square root of 3 over 2. So, right, tangent of pi over 3 is going to be the square root of 3 over 2 divided by 1/2, which is simply square root of 3. So this is equal to the square root of 3. So let's go ahead and substitute back, or use the fundamental theorem of calculus on this, and you get 8 times, right, you're evaluating that, 8 times the square root of 3. All that I'm doing now is substituting in square root of 3 for this expression. So it's 8 the square root of 3 plus 8 the square root of 3 cubed over 3 minus 8 plus 8/3. So let's do a little bit of radical math here. This is the equivalent of 8 the square root of 3 plus, grab another ink, right, the square root of 3, this is an aside, okay, the square root of 3 cubed is the same thing as the square root of 3, right, times the square root of 3 times the square root of 3. This is just 3 times the square root of 3, okay? I'm guessing that this student stumbled a little bit on the radical math and couldn't close on it. So this is 8 times the quantity 3, the square root of 3 over 3 minus, all I'm going to do is put them all over 3. This is 32/3. Grab a common denominator, okay? And likewise, I'm going to write everything in over 3. So 8 square root of 3 is just 24, square root of 3 over 3, plus 24 the square root of 3 over 3, minus 32 over 3, which is equal to 48 the square root of 3 minus 32 over 3. And that indeed is the answer to this problem. So I hope this helps.